We would like to present our final project. The name of our team is the Data Crunchers. The team is Kiro Bell and myself, Douglas. As you know, during all these weeks, our main focus was to use Microsoft Azure and machine learning, and we was working different type of algorithms to discovering some structure, algorithms to predict some categories in the data, to predict some values. And this is our main focus in our project. We will use clustering algorithms, we will use two-class classification algorithms, multi-class classification algorithms, and also we will use regression algorithms to answer some of your questions. Then the main idea here for the clustering was try to discover the structure of the data set, and it was a German band data set. We use k-mean, as I said before. The data set is 1,000 rows, 21 columns, and we want to answer and understand how many clusters or clustering groups are in the German bar data set. As you know, we was using Microsoft Azure Machine, and we was able to use some columns in the data set, normalize to do some classifications, and we use the k-mean clustering. The main parameters was parameter range for the criteria trainer mode. We used the metric was the Euclidean and 10,000 iteration. After to run that, we got this number of cluster. As you can see here, we have 0 to 6, 7 cluster. Using this algorithm, well, was really good. Look, the distance is almost like the same. Then we have kind of a very good average distance to the clustering center. They are from 0.4 to 0.5. And to answer the question, how many cluster or group are in the band data set, a good number should be 7. Now, using another type of algorithms to predict categories, we was using this particular one. We use 4 different types of multi-class classification algorithms. The idea was to identify some digit recognized coming in kind of a file when we have 42,000 rows and 785 columns, and represent a pixel. Each row represent a number of pixels of the pictures, and we need to identify number from 0 to 9. We was able to create different cases for logic, to use logic regression, neural network, multi-class decision forests, and multi-class decision jungles algorithms. We use 7030. We got this. We got for this particular case, the best algorithm for multi-class classification was multi-class neural network with an overall accuracy of 0.97 and average accuracy of 0.99. Then to answer the question, each algorithm, which is the easy or the more accuracy number, or the difficult or the worst accuracy number to recognize, for multi-class logistic regression, number 1 was the easy one, or the better accuracy. With the less accuracy or worse accuracy was number 5. Sometimes here you can see the number 5, the algorithm got confused and say there was number 3. For the neural network multi-class algorithms, the easy one to recognize was number 6. The worst case was number 3. For multi-class decision forest, the easy one was number 1, more accuracy number 1, less accuracy with number 3. And for multi-class decision jungle, the easy one or the more accuracy was with number 0, where the worst accuracy was with number 5, where sometimes 9.2% of the cases where it was a number 5, they confused with number 3, and 4.5% of the cases where it was really a number 5, they confused with number 8. Now, what more we did in our project? We worked with another data set to work with the regression to try to predict some values. We use a data set, Russian data set. It has 30,471 rows, 292 columns. We try to use only 2, linear regression and neural network regression. In this particular case, because the number of columns was a log 282, we tried to discard as much as we can and be able to work better, discard some of the information, some of the data. We try to, because we want to predict price, we try to work in a range of price that will be quite easy, more easy to work. We use some SQL transformation to discard some of the price of the house and was so high or so low, and be able to concentrate in the good data. Try to minimize the error or the noise creating for values that are or very, very low or very, very high. We normalize some of the data, and we was able to compare these two algorithms. And here are the results. On the left side, we have the distribution of the price. Here in the middle, we have how is the mean absolute error for the linear regression and the neural regression. As you can see, it's almost like the same. Is better the linear regression for the mean absolute error. But the neural network regression has a better root mean square error. Of course, these values, every time we need to compare with what we want to predict, which values we want to predict, to understand then is this a good or no good prediction. In this case, I think so room to improve, but I will say that is quite good.